So hi guys, welcome back to another video. So in this video I will be talking about uh, three important topics of JavaScript, that is let versus var versus const. Second one is code execution and hosting. Third one is closures. So these three topics are we are going to cover today. Yeah, so screen is visible. So let's discuss let, var and const. So the main difference is between is let, var and const is their scope. So let and const are block scope, which means you define them inside. Their scope is only limited to this block. This is what a block is. Basically, curly braces, opening curly braces. This is what a block is, right? Their scope will not go beyond. You cannot access const and let variables outside this scope. Whereas var is function scope, you can access it inside the function up to the function scope. So like I have declared x and y variables. X is declared using var and let, y is declared using let. So x can be accessed even before declaring the variable, but y cannot be accessed. Why? Because it is hosted in a different manner. It is hosted in such a manner that y will not be given any value before declaring the variable. So that will be called as a temporal dead zone below above the declaration of the let variable. So you cannot access it. If you try to access it, then it will give you a reference error saying that has it has not been declared. If you try to access it outside the scope, like line number 15, then it will give you a reference error because its scope is only limited to the block, this block, right? But you can access the variable declared using var, that x can be accessed but y cannot be, right? So let's just run it. So you are getting undefined. Why it is giving undefined? Okay, it was written before the declaration, that is why it is giving undefined. Y is 120 and x is 12, right? Now let us talk about lexical scope. So suppose you are given this function where you are declaring x inside test function, then test2 is declared inside test function, y is declared inside test2 function, test3 is declared inside test2 function, and z is declared inside test3 function. Now can you access the variables x, y and g inside test3 function? Of course. Why? Because of the closures. Function closure is nothing but a function bundled with its lexical environment. What is the lexical environment? The uh, environment outside the function declaration. So for test 2, test is test and the global execution context is the lexical environment. For test 3, test 2, test 1, test and global execution context is the lexical environment. So let's see this in action. If I run the script, we will be able to access all the three variables. Now let's see the memory diagram of this. Let me run the script. Open with live server. Yeah, it is open now. Command Shift I, and let me rerun it. So as you can see, we are inside test function. So it is giving us x test2. X is defined. X is getting undefined because it has not been executed. Line number 3 has not been executed, and test2 is declared with its own whole memory code. So if I go one step ahead, it will override the undefined value of x. It has been executed. Now it will go inside test2 right, as you can see in the call stack. Now test2 is forming a closure with test, which having a value as x. Now if I hit the next arrow, then it will go inside test3. test 3 will form a closure with test 2 and test, right? It is forming a closure with test 2 and test. Z will be undefined because it has not been executed yet. So if I hit again the next key, then all the variables have been declared and initialized their value. That is why we are able to access it. So let's see the memory diagram of it. Where is it? Okay, I think I saved it somewhere. YouTube. Global execution context is there. Inside it, test will be there, right? Test, inside test we will be having x and test2 function. Inside the test2 function we will be having y and test3 and a closure with test function. Inside test3 we will be having closure with test2 and test function, and we will have z. So that is why it is able to test3 is able to access x, y and z, all of three variables, because it is forming a closure with the other two, right? So this is the memory diagram. Now let me talk about caching closures. So closures is done. Closures is nothing but a function bundled with its lexical environment. That's it. Now, what do you mean by caching? Caching means to improve the computational power. If the code has been pre-computed, why we need to compute it again? If we are calling it again, then it can be cached and return the same value. So let's talk about caching. So let's say we are given a function sum. We need to implement a function sum which takes in the array as an argument, and if we are calling it again and again, it is going to give us the output. uh, doesn't have to recompute it, but it will give the output if it has already been computed. So what we need to do here is we need to declare an object that will be cache. So why object has of one lookup time, and they can be used to store key value pairs. So we will be storing a key versus value pair. Whatever array is passed, we will just typecast it into string, and we will store it as a key of the closure, key of the object. And if it is already there, then we will return the key, return the computed value. If it is not, then we will compute it, store it in the cache, and return it, right? So this is what caching closure means. So now let's talk about a couple of questions regarding closures. So let's say we are given a function like this. We need to build a function like this that can be called multiple times with variable arguments, and it gives the sum of all the arguments. So how we can define it? We can define it like this: sum a, the parameter inside it. If the parameter is not defined, then we will return 0. If the parameter is defined, then again we are calling it. So we will have to return a function. So we are returning a function, then we are having another argument, because it can have again the argument. So if it is there, then we will return the sum of a plus b. If it is not there, then we will simply return a. Right? So this is the output. So yeah, that's it for this video. In the next video we will be covering functional programming and array methods and string methods. So yeah, that's it for this video. Thank you guys.